Hi, and welcome everyone. Today we're talking about something you've probably heard a lot: LiDAR and point clouds. What are they? How do we get them? Where do we use them? And most importantly, how do you actually process them? This tutorial explains LiDAR technology and point cloud data. You will learn how LiDAR works, how point clouds are generated, where this data is used, and the standard workflow for processing it. What LiDAR is. LiDAR stands for light detection and ranging. It is an active remote sensing technology that emits laser pulses toward a surface. The sensor measures the return time of each pulse. This time of flight measurement is converted into distance. When repeated millions of times, LiDAR produces a highly accurate three-dimensional representation of the environment. What point clouds are. A point cloud is the raw output of a LiDAR survey. It contains millions or billions of points. Each point has X, Y, and Z coordinates. Some systems also record additional attributes such as intensity, return number, RGB color, and classification. Point clouds form the basis for terrain models, building models, vegetation analysis, and engineering measurements. How point clouds are acquired. Point clouds can be produced using different acquisition platforms. 1. Airborne LiDAR. Laser sensors mounted on drones, helicopters, or fixed-wing aircraft. Best for large area mapping, terrain modeling, forestry, flood analysis, and corridor mapping. 2. Terrestrial laser scanners. Tripod-mounted scanners used at ground level. Suitable for architecture, construction verification, industrial sites, tunnels, and high-detail engineering surveys. 3. Mobile LiDAR. Sensors installed on vehicles. Used for road mapping, power line inspections, railway corridors, and urban environments. 4. Bathymetric LiDAR. Green wavelength lasers capable of penetrating water. Used for coastal surveys, shallow rivers, and underwater terrain mapping. 5. Open source and government data. Many institutions publish ready-made LiDAR datasets. Sources include OpenTopography, USGS, and regional GIS portals. Major use cases of LiDAR data. LiDAR and point clouds are used in multiple professional fields: topographic and engineering surveying, digital terrain model and digital surface model generation, urban planning and building reconstruction, road, railway, and utility corridor design, forest canopy analysis and biomass estimation, mining volumetric calculations, flood risk modeling and hydrological studies, construction progress monitoring and BHM workflows, archaeology and heritage documentation. Point cloud processing workflow. The processing workflow typically follows 5 main stages. Step 1. Data import. Load loss LAZ, E57, or PLY files into processing software. Common tools include Cloud Compare, Global Mapper, LiDAR 360, TerraScan Recap, and QGIS LiDAR plugins. Step 2. Pre-processing. Pre-processing includes removing noise points, merging multiple scans, aligning scans using ground control points, georeferencing, filtering outliers. This stage ensures data quality before classification. Step 3. Point classification. Classification assigns each point to a specific category. Typical classes include ground, low, medium, and high vegetation, buildings, power lines, water, bridges, noise. Accurate classification is essential for terrain extraction, volumetrics, and modeling. Step 4. Derived products. From the classified point cloud, you can generate digital terrain models DTM, digital surface models DSM, contours 3D textured meshes, building models, tree metrics, slope and aspect maps, volume calculations, orthophotos, photogrammetry workflows. These products support planning, engineering, environmental, and construction applications. Step 5. Export and integration. Export the outputs into CAD GIS or 3D modeling formats such as DXF, SHP, GeoTIFF, OBJ, or E57. These files can then be used in platforms like AutoCAD, Civil 3D, ArcGIS, Revit, or Blender. In conclusion, this completes the overview of LiDAR technology, point cloud acquisition methods, typical applications, and the full processing workflow. The next tutorial will focus on hands-on processing using Global Mapper. You can also watch other related contents, like drone surveying and other important videos on this channel. Don't forget to subscribe, like, and share. Thank you for watching.